In this video, we're going to talk about the difference between a relation and a function, and then learn several things about functions, such as function notation, x and y intercepts, and how to tell what the domain and range of a function is. So a relation is just a set of ordered pair. The set of x values, the first coordinate is going to be your domain. The second coordinate is going to be your range. Now, the definition of a function is that if it's a relation, set of ordered pairs, then we're going to say y is a function of x if for each value of the x in the domain, there's exactly one value of y in the range. So you'll hear this kind of shortened up to say that when you have a relation where the x's do not repeat, then you have a function. So the x's cannot repeat. So let's look at several examples of how to tell whether or not a relation is a function. So every example on this page is a relation. So the question becomes, is the relation a function? So when it's a set of ordered pairs, we quite simply look at the x values. So this x value is 2, this x value is 2, and this x value is 3. If you have repeating x values, then you do not have a function. No repeating x values. So since I have 2 points that share the same x with different y's, this is not a function. Okay, so let's look at the next one. We see here that this x value in this point is 1, this x value is 2, this x value is 3. There's no repeating x value, so yes, this is a function. Okay, continuing. Now, this is what we call a map. Okay, or a mapping. Sometimes you'll hear it called a mapping from the x to the y. And you see all this is you can still read your ordered pair, an ordered pair of -2, -2, 6, 6, and pi, pi. Those would be the ordered pair created by this mapping. Notice that -2 does not go to 2 different y values. 6 doesn't go to 2 different y values, nor does pi. Therefore, this is a function. Okay? Now, when you're dealing with an equation, how do you tell when it is a function? In essence, what you're looking for is something that can be solved with y, solved for y. Now, it doesn't have to be solved for y, but you should be able to solve it for y. Because again, the key there is there can be no repeating x values. So for every x, you're going to have to get a different y value. So when you think about y equals 2x plus 1, no matter what I put in for x, I'm going to get a different y value out. So this is, yes, it's a function. We're going to learn throughout the course of this unit that y equals 2x is a line, and all lines are functions except for vertical lines. Okay, y equals 2x squared. Again, when I put any numbers in for x and I square them, I'm going to get one y value out. I put 1 in, 1 squared is 1, 2 times 1 is 2, plus 6 is 8. I put -1 in, well, I'm going to still get positive 8, but by putting +1 in, I don't get a different y value, okay? So this also is a function. So you're looking for things where I can put in a value for x and get 2 different y values out. Those are not functions. So let's look at this next one, number 6. X equals 7 minus y. Now, it's not solved for y, but I could easily solve this for y using the techniques from the first section we went over. So I could say, subtract 7, so that's x minus 7 equals -y, divide by -1, and I get -1. X plus 7 equals y. And so, yes, this is a function. Again, it's a line. Because when I put an x value in, I'm only going to get one answer out. Now, number 7 is a little trickier, and I will tell you up front, this one is not a function. And the reason it's not a function is because if I put in, let's say I put in 1 for y. Sorry, 1 for x. When I solve, I'm going to subtract 7. That gives me negative 6. Which, when I divide, I'm going to get y squared equals positive 6. One of the things we're going to learn in this class, when I take the square root to solve, that's plus or minus the square root of 6 is y. Well, that's two different y values for this one x value I put in. So that's not a function. Okay, when I do the same thing over here, let's say I do the same exact thing. 1 in, this is y cubed now. This is negative 6 equals negative y cubed. So positive 6 equals positive y cubed. When I take the cube root, it's a little bit different because cubed roots can be positive and cubed roots can be negative. So this is going to give me y equals the cubed root of 6, not two different answers. So this is, yes, it's a function. So how do we look at a graph and tell whether or not it's a function? Well, you're still looking for those repeated x values. For graphs, we always look at what's called the vertical line test. And it is basically, can I draw a vertical line through the graph and intersect more than one point? If the answer to that is yes, then my graph is not a function. Because again, if I draw a vertical line and I hit the graph more than once, then what I end up with is repeating x values. So look at this first one. So if I draw a vertical line on this graph, the question is, will I hit two different y values? And the answer to that is obviously yes, because I can draw a vertical line right here, and I've got that value and that value. So this is no, it's not a function. So look at this next one. Think about drawing vertical lines through this graph. Are there any vertical lines going to touch this graph in more than one point? And as I go through, you can see that no matter where I draw, I'm only going to hit one point on the graph. So therefore, this is a function. So let's look at this next one. Again, drawing vertical lines through the graph. I'm all good on the left. If I look on the right, I'm all good on the right, but I have a problem. If I draw a line through the y-axis, this and this is repeating x values because they're both shaded in circles. So this is no, it's not a function.